Hi, welcome to the course on classical physics. So, as promised, we are launching the course now. We have reached 600 subscribers, and the plan is to cover this entire topic over the next few months. So, there will be lots of videos there. I anticipate greater than 30 videos in this course. And the topics covered will include all of Newton's laws of motion, uh, your conservation laws, energy and momentum, and conservation of energy momentum, then non-inertial frames, rigid body dynamics, non-inertial frames, rigid body dynamics, RBD. Then there will be Lagrangian formalism, Lagrangians and Hamiltonians, Lagrangian formalism. There will be orbital mechanics, basically gravitation and details of that. Then oscillations, waves, and even probably fluids. So this covers basically all of 11th standard and even more. We will do it, however, not at the level that is required for JEE Advanced. We'll do it at a slightly higher level. JEE Advanced, if you want to prepare for that, you need to go through, say, HCV, DC Pandey, Hirodov. These three books should be more than sufficient for JEE Advanced. However, what we are targeting here is Physics Olympiad. So we will be working through a set of undergraduate textbooks. So we will be working through David Morin, Griffiths for some portions, and other textbooks that I'll tell you when the time comes. So let's just begin the course. And the first video that I have for you is it's a very basic video and a short video about vectors. So for vectors, I would recommend you look at chapter 3 from HCV, volume 1, which is the vectors, basic mathematics chapter. The vectors will be there in that. Also, you can look at NCERT 11th and 12th books, NCERT 11th and 12th math books for the chapter on vectors. So if you go through these resources, you should understand fairly well what are vectors. So I will quickly discuss basic properties, but what I want to touch on in this video is a conceptual idea of defining the meaning of a vector precisely. So let's just begin. So you probably know that vector is something that has a magnitude and a direction. And I will not be covering like the basics of operations on vectors. I'll just briefly outline them. Any vector A can be written in terms of three components in the coordinate frame that we decide. So we can decide our XYZ frame. This is, say, x-axis, this is z, and this is y. So any vector in this can be broken down into three components. So if this is an A vector, it will have a AX component, AX I cap, and it will have some AY component, AY J cap, and it will have some Z component as well. This component is your Z component. If you take a projection of this on the XZ plane, so this component will be your AZ K cap, right? So any vector can be written in terms of components in the three basis vectors. So our basis vectors are the IJK vectors. IJK basically are unit vectors in the three directions of our coordinate frame, right? And this is a choice that we have made. So we can choose our unit vectors like this. We can even choose a unit vector in some arbitrary direction. So basically what we are saying is every vector can be broken down into three components: X component, Y component, Z component. If you have this, then you can do operations of A plus B just by doing AX plus BX I cap plus AY plus BY J cap plus AZ plus BZ K cap, right? You just add the components individually and that gives you the sum of two vectors. If you have to do product of two vectors, however, right? Sum and difference is covered like this. Product, however, has two variants. So one is a dot product and one is a cross product, right? So dot product basically takes two vectors and outputs a scalar quantity. So dot product input is two vectors and gives out a scalar, whereas cross product input is two vectors and gives out a vector quantity, right? So this is the basic meaning. Now the way it is defined is A dot B is equal to AB cos theta, where A and B are the A is equal to mod of A vector, or the length of A vector. B is equal to mod of B vector, and theta is angle between A vector and B vector. Angle between A vector and B vector. So in terms of components, the way we do A dot B is split it as AX I cap plus BX J cap plus AY J cap, AY J cap plus AZ K cap, and do a dot product with BX I cap plus BY J cap plus BZ K cap. And when you do a dot product, I dot I will be equal to 1. You need to know here that I dot I is 1 because the length of I and I is 1 and 1, and cos theta is 1 because theta, the angle between I and I, will be 0 degree, right? I and I basically are unit vectors in the two same directions, so this will be 0. I dot j is going to be 0. I dot k is going to be 0. K dot j is going to be 0. Basically, all the basis vectors, if you take unit vectors, the same unit vectors, when you do dot product, they will be 1, but if they are different unit vectors, they will have a dot product of 0 because the angle between them is 90 degrees. So cos theta will become 0. So you can simply multiply by doing multiplication as if it's a 3 terms polynomial, right? You just multiply this with this, this with this, this with this, right? You get ax bx, I dot I is 1, plus ax by will be 0 because I dot j is 0, plus 0 plus 0 plus 0 plus ay by plus 0 plus 0 plus 0 plus az bz. So basically the answer here comes out to be ax bx plus ay by plus az bz. Only the components which are matching I and I, those components multiply, and because I dot I is 1, other components disappear. So this is the number or the scalar output that comes when you do a dot product, right? What about cross product? In cross products, the way it is defined is A cross B is equal to A B sine theta and n. Now n is a unit vector in the direction perpendicular to the plane, perpendicular to the plane of A and B, perpendicular to the plane of A and B, where A and B are magnitudes. So if you have two vectors like this, A and B, n direction will be something perpendicular to this particular plane that is defined by them. So this gives a vector with this particular magnitude. How do you do the calculations? It is again very easy. Ax I cap plus ay j cap plus az k cap cross product with bx I cap plus by j cap plus bz k cap. When you do cross product, you have to realize that there is a rule for I j k. So you will have I cross j will be k, and this clockwise circle is followed. So I cross j will be k, j cross k will be I, and k cross I will be j. If you reverse the order, j cross I will be minus k cross j will be minus I, and I cross k will be minus j, right? So this order is true, and if you do I cross I, j cross j, k cross k will be 0. So I will leave it up to you to figure out how to multiply these two vectors with cross product. The idea is basically just do this cross this and check what is I cross I. I cross I is 0, so that component is 0. I cross j if you do, right? I cross j if you do, it will be k. So you'll get ax by k, and I cross k, if you do, it will be minus j, minus ax bz k j, minus ax bz j, and so on. So keep writing the terms like this and follow this rule, follow this clockwise rule. When you go clockwise, the I cross j will be k, j cross k will be I, k cross I will be j. So these operations are there in every standard reference that you will look at. You should look at NCERT, you should look at HCV and figure this out. I will not be covering this in this video. So the focus for this video for me is to understand the meaning of vector. So the definition that a vector is a magnitude and a direction, any quantity with magnitude and direction, is not very satisfactory. Magnitude plus direction, that definition doesn't mean a lot. What we want to do is precisely specify what it is, right? So instead of that, if someone says a vector is a quantity that combines properly under addition, combines properly under addition. By properly, we mean combines just like a displacement combines under addition. Properly under addition. So what do we mean by this statement? This is a slightly better definition of a vector than that. What is the meaning of properly here? Like a displacement. So displacement is the model on which vectors are based. So if your quantity behaves like a displacement, it is going to be a vector. So let's analyze this with an example that is taken from David Griffiths. So David Griffiths has written a wonderful book on electrodynamics. You should definitely buy that book as a resource. And that book has the first chapter of vector analysis where he gives a very nice analogy. So I'm going to explain that to you. So suppose you have a box with some fruits and you define a quantity like this. N is a quantity which is written like a vector, but nx actually denotes number of mangoes in the box, number of ny is apples, and nz is bananas, right? Now this quantity, it is defined in the same way as you define a vector, but is it a vector? We have to understand this. So let's define another quantity like this, mxi. This is another box with apples, mangoes, and bananas, right? mzk, right? This is a different box with the same fruits. Okay. So if you add m plus n, you can clearly say that I will add components separately and I will get nx plus mx mangoes I plus ny plus my apples in j plus nz plus nz bananas in k, right? So since you are able to add these two quantities m and n in such a way that you add the appropriate components with each other. So you're adding apples with apples, mangoes with mangoes, and bananas with bananas. So it is combining properly under addition, just like a displacement. So basically what I'm saying is I have defined something like this. And I'm asking you a question, is it a vector, right? It seems to have components just like a vector. It is adding also properly just like a vector. But obviously, you know intuitively that this is not a vector, right? Obviously, there is no sense of direction here. So what I want you to question for yourself is, what do you really mean by direction? Or what is the meaning that is inherent in your intuitive understanding that this is not a vector? Why is this not a vector? And because it also has three components and it is also adding like a vector, right? So the idea here is this. So the vector n that we defined does not transform properly under addition, properly under a rotation of the coordinate frame, properly when you change the coordinate frame, when you change the coordinate frame. So what do we mean by this state? This is the answer. This is the explanation for why n is not a vector. But let's analyze this a little more deeply. So think about a normal vector, and let's say this is a vector A, and this is your y-axis, and this is your x-axis, let's say, right? And this angle is theta, correct? And now I transform my axis and rotate my axis by a little, right? So my new axis is like this. This is my new x dash, and this is my new y dash, right? So in your new axis, can you find what the vector will be? So a vector, if you write in the normal original x-axis, you know that ax, this part will be your ax, and this part will be your ay, right? So we know that ax is equal to this length, let's say, is a cos theta, and ay is equal to a sine theta, right? We know this. So we can write a vector in the original axis as a cos theta I cap plus a sine theta j cap, right? Now, suppose I rotated this by an angle phi, right? Rotated the original axis by an angle phi. Clearly, if you twist your head and look at it from this perspective of x dash, y dash, this vector is a slightly different vector because this angle is different. It is theta minus phi now, right? So therefore, your ax dash is now a cos theta minus phi, and ay dash is now a sine theta minus phi. So expanding the trigonometric formulas here, you get ax dash is equal to a cos theta cos phi plus a sine theta sine phi. And a cos theta was what? A cos theta was ax original. So that is ax cos phi, and a sine theta was plus ay sine phi, right? So your new vector ax is actually coming by this calculation, right? Ax original component into cos theta plus ay into sine theta, sine phi. And phi is the angle by which you rotated it, right? And what is your ay component now? Ay component is a sine theta cos phi minus a cos theta sine phi. And this can be written as a sine theta is your ay. So ay cos phi minus ax sine phi, right? So understand what has happened here. What you realized is that once you rotate your coordinate frame, obviously the vector has become some new vector a dash, right? This a dash vector is basically ax cos phi plus ay sine phi in the I dash cap, in the I dash vector direction, and ay cos phi minus ax sine phi in the j dash direction. This is your basically I dash, and this is your j dash direction, right? So what we understand here is that vectors always transform or change when you change the coordinate frames. So basically, if you rotate the coordinate frames, the vector will change to a new vector, right? However, think about it. If you took the original m or n vector, n quantity that you talked about earlier, which was mangoes, pears, mangoes, bananas, and apples, right? This was the quantity that we were discussing earlier. And this was like, this was mangoes, and this was bananas, apples, and this was bananas in a box, right? Now we were questioning whether this is a vector or not. But you realize that if you transform your coordinates, if you start looking instead of x, y, z like this, if you rotate it by some angle, will this quantity change? No. This quantity is invariant under rotation. This quantity is an invariant or doesn't change if you transform under rotation of the axis, right? So that gives us a clue of why this is not a vector. Think about it. If there was a displacement, if you moved certain distance and you looked at it, if suppose someone moved like this and you looked at it under y and x axis like this displacement is denoted by a vector. But if you change your y and x axis to be looking like this, then it is obviously a different vector in that axis, right? So what the rule that you should keep in mind is that vectors always transform under rotation or change of coordinates. However, any quantity that does not transform like a displacement, any quantity that does not change itself like a displacement changes itself under rotation is not going to be a vector, right? So I will define a vector properly now. So this is our conclusion of this video. This is an answer for what is a vector. So a vector is any set of, a vector is any set of three components that transforms or changes in the same manner as a displacement when you change the coordinate axis. So basically, if you rotate the coordinate axis, then your vector should change in the same way like a displacement is changed under that rotation. So if that is true, if the quantity that you are investigating is behaving in the same way like a displacement under a change of coordinates, then that quantity is a vector. So as we go further in this course, we will be talking about things like pseudo vectors and all, pseudo vectors and pseudo scalars and stuff, and where we'll be revisiting this idea that a vector is something that behaves like a displacement. So keep that in mind. Anytime you see a quantity and you have to decide whether it's a vector or not, it is basically something that behaves the same way like a displacement under transformations of the coordinate axis. So examples of pseudo vector could be torque. Torque is a classic example. It's not a real vector, torque. So we will come to these ideas later. For now, this is it. And please go through the references that I mentioned at the beginning of the video. You should look through HCV. You should go through your NCERT vectors chapter. And that will be enough for us to begin the course in physics. So the next videos will be details of physics. So this was all the maths introduction that I will do. By the way, you should also look through the differential calculus and integral calculus basics. Differential and integral calculus basics will be essential in this course. So if you don't know what to do, there are several videos on my channel where I introduce differential and integral calculus. I'll try and put them in the link to this video. If you are a beginner and don't know calculus, you should go through those videos in detail and also refer to your NCERT 11th and 12th maths books for basics of calculus. Like you can go through the functions chapter, sets relations chapter, and also basics of differentiation and basics of integration. But better option would be to just watch my videos. There are several introductory calculus and integral calculus and differential calculus videos on the channel. I will put links to those in the description. Okay. So I need you guys to go through the math basics by yourself so that we can focus on the physics. So I'm not going to be spending time explaining basic maths. You have to put in that effort, go through the videos on my channel, and I think it should be fairly easy. So that's all for this video. I'm excited to bring more content to you guys. Please like, share, subscribe to the channel, share it in your groups, tell your friends. That's it for now.